Hello, mic check. Hello. Hello, mic check. Hello. Hello. Hello, mic check. Hello. Yeah. Hello. వాయిస్ తగ్గించండి, నా దాంట్లో సౌండ్ తగ్గించండి. హలో. హలో.
morning, children. Yesterday's class I have discussed about this nomenclature of compounds. So I have given a large number of examples and I advised you to practice. I hope you have done that cases, because if you are able to know the name of the compound, then learning organic chemistry becomes easy. So that's why I have given ample of examples. Right, children? Now in today's class I am going to discuss about methods of preparation of amines. So we do have a lot of methods to prepare amines. It's very important, mainly for objective examinations. Most of the time they are asking question from ammonia compounds, that is amines, and again substituted amines. Right, children? So here most common methods are reduction only. There are so many reduction methods we are going to use. So whenever we are talking about reduction methods, you should recall the reducing agents. This we have studied in the first year. In general chemistry, GOC, general organic chemistry, we have given oxidants, reductants, strong reductants, mild reductants, strong oxidants, mild oxidants, and specific oxidants and specific reductants. These are all given in the first year. Right? Now we will take the methods of preparations. The first method, methods of preparation of amines. First one is ammonolysis method. Ammonolysis of alkyl halides. So what is ammonolysis? Here ammonia which is treated with alkyl halides so that it gives substituted compounds. Those are amines. Let us see the example. I take ammonia, children, and treat it with alkyl halide. You can take alkyl chloride or alkyl bromide. But generally bromide is better because it is a better leaving group, bromide, when compared to chloride. Now you see this one. Nitrogen is carrying a lone pair of electrons. So it acts as nucleophile. So therefore this nucleophilic substitution takes place on alkyl halide. So when you take this one, this is the compound formed RNH3X plus minus. This will attack this one, RNH3 plus X minus. This is a salt. So this one treated with NaOH solution, then you will get RNH2 plus NaX plus H2O. That means whenever this ammonia is reacting with alkyl halide, right, we will get alkyl ammonium halide. It's a salt. So from this we can extract the ammonia by treating with NaOH. When you treat this with NaOH, you will get amine and NaX and OH and H, H2O. Right, children? So this is the one, what we get is primary amine. And children, here the mechanism followed is SN2 mechanism, substitution nucleophilic bimolecular, you know that. So SN2 is a single step mechanism. That means whenever the nucleophile is attacking, at the same time leaving groups leaves. So now when you take this primary amine also acts as nucleophile. Again it acts as nucleophile. This is nucleophile and this is also acts as nucleophile again. That means this will react with one more alkyl halide, so that we get R2NH. So this is secondary amine. Again this acts as nucleophile. So it combines with again alkyl halide, then R3N. This is tertiary amine. Again this tertiary amine combines with one more molecule, gives R4NX plus and X minus. This is quaternary ammonium salt. Quaternary ammonium salt. Now you see the children, here this is a reaction. What do you say? That substitution, nucleophilic substitution, bimolecular reaction. So what is the nucleophile here? Ammonia molecule carrying a lone pair. Therefore this ammonia when reacts with alkyl halide will get primary amine. When you see the primary amine also acts as nucleophile, since NH2 group carries a lone pair, so that it reacts with one more molecule, so that we will get secondary amine. Secondary amine again takes one more molecule, we will get tertiary amine. Tertiary amine takes one more molecule, so that finally we will get quaternary ammonium salt. So by seeing this you can get one idea, right children? By seeing this you can get one idea. What is that? So this is the reaction. We get a mixture of amines. We get primary, secondary, tertiary and also quaternary ammonium salt. So therefore this is not the comfortable reaction to prepare amines, because we get a mixture of amines. In this we get a mixture of amines. So whenever we get the single product, normally yield will be more, because when you are getting a mixture of compounds, yield is less, right? Even then we can get amines, but it is not very comfortable, because of we get a mixture of amines. Like Wood's reaction, you know that Wood's reaction is always used to prepare the alkanes with even number of carbon atoms. So when you take alkyl halides with same number, so that there is no problem, but one is even number and one is odd number, so that it gives a mixture of compounds. That's why there also we cannot use that particular reaction. So whenever a reaction yielding a mixture of compounds, that is not a better method, because in that reaction we get a mixture of compounds, but sometimes the separation also becomes difficult. Right children? And then one note here. Suppose if I want to stop a reaction to some extent at the first step, yes, there is a possibility. That is, if you take excess ammonia, then we get a primary amine. So this is somewhat, when you are taking excess ammonia and excess ammonia treated with alkyl halide, so that the reaction is stopped at somewhat primary stage. Why? Because when you take excess ammonia, so this will take alkyl halides and convert it to primary amines. So it can avoid the conversion of this alkyl halides into secondary tertiaries, right? This is the one, first one, ammonolysis. Second one, children, reduction methods. Reduction methods. There are so many reduction methods in which we get amines. So, reducing agents. You know, we have reducing agents so many. The strongest reducing agent, lithium aluminum hydride, and again hydrogen in presence of catalyst, that is H2PD, H2PT, H2Ni. This is also one. Again, sodium with alcohol, sodium metal with ethyl alcohol, that also acts as a reducing agent, right children? Again, SnHCl, FeHCl, right? There are so many reducing agents we are going to use for the reduction process. And which compound should be reduced? Yes, the compound should be reduced are nitriles, isonitriles, amides, right, oximes, nitro compounds and azides. So we are going to see the 6 types of reductions in this, right children? For most of the reactions you can use the same reducing agent. Whenever you use strong reducing agents, then the corresponding group is converted to amino groups. So amides. Let us see this reactions one by one. The first one, reduction of nitriles. Right children? Reduction of nitriles, that is OR triple bond N. This nitriles on reduction with lithium aluminum hydride. Right? Lithium aluminum hydride is a strong reducing agent, or H2 and metal catalyst. Metal means nickel or palladium or platinum, you can use this one. Then this group is reduced to RCH2NH2. This is a primary amine. That means nitriles are reduced to amines. C triple bond N is reduced to CH2NH2. CH2NH2. So you can take a proper alkyl group. Suppose if I take a methyl group as alkyl group, then same reducing agent, the CH3, don't change this one. This is CH2NH2. This is ethanamine. Ethanamine, right children? That means this is a chemical reaction in which we get one carbon extra. This is ascending reaction, we called as ascending reaction, that amines with more number of carbon atoms. Because I have taken a methyl group, alkyl group with one carbon, but here the alkyl group with 2 carbons. If I take ethyl, you will get propyl. If I take ethyl, I get propyl. So it is a ascending reaction. Ascending reaction. Right children? So this is the one important reaction, conversion of nitriles to amines. You know how to get nitriles? Nitriles, you know that nitriles is very simple. You can take all alkyl halides with KCN. So aqueous or alcoholic. Then we will get RCN plus X minus. It's a strong nucleophile. Cyanide ion is a strong nucleophile. So it can replace weak nucleophile, that is halide ion, so that you will get alkyl nitriles. So definitely we get amines from alkyl halides in two steps. Alkyl halides are treated with Cn minus, so that you will get alkyl cyanide or alkyl nitrile, which on reduction gives amines, right children? This is the first method. Then we go for second one. From isonitriles, that is isocyanates. So you can take N triple bond C. This is isocyanate. Again reduction, you can take lithium aluminum hydride or H2 metal, nickel or platinum or palladium. Then we will get or NHCH3. So here you get a secondary amine. Nitriles gives primary amines, isonitriles gives secondary amines. Just you take example. For example, I take C2H5, N triple bond C, then same reagent on reduction gives C2H5 NHCH3. This is a secondary amine. What is the name of this one, children? N-methyl ethanamine. N-methyl-ethanamine. This is N-methyl alkanamine. Alkyl group is ethyl. Ethyl is bigger one compared to methyl. N-methyl-ethanamine. N-methyl-ethanamine. So this is the second one. And third one, children, from azides. So I take alkyl azide N3, take this lithium aluminum hydride. I am taking strong reducing agent. This azide group change to NH2 plus N2. This is the compound. So alkyl azide gives alkyl amine plus nitrogen is left. Azide group N3 minus, that structure we have studied in many places, just remember the structure. So suppose if I take CH3 N3, then you will get CH3 NH2 plus N2. CH3 NH2 plus N2. Right, children? Then I can go for amides. From amides, you know the children, RCONH2. This is the amide. This is treated with LiAlH4. You can take H2O, lithium aluminum hydride. Then what will happen? This can be reduced to RCH2NH2. This is amine. It is a primary amine. RCONH2, this is amide group, is converted to amino group CH2NH2. CH2NH2. Right, children? Example, you can take R. In place of R is methyl, ethyl, propyl, aryl, whatever it may be, then you will get the corresponding ones. Suppose if I take substituted amide or NH R dash or R, that is NH2 group. This is amide, CONH2 amide. This is alkyl substituted amide. Right? Then same thing, there is no change here. Only you can get this RCH2 NHR dash. There is no problem about this substitution. Suppose if I take RCO NR2, R dash R double dash, then you will get same RCH2 R dash R double dash. If you take amide, you will get amine. If you take substituted amide, you will get substituted amines. Substituted amines. It's a very simple reaction. If you just remember one point, then this is NH2 CO. CONH2 is amide group. This is alkyl substituted amide, dialkyl amide. This is alkyl amide, dialkyl amides. This one. That means N-alkyl alkanamide, NN dialkyl alkanamides. Right? Amides are alkanamides. Amines are alkanamines. Amides are alkanamides. So N-alkyl alkanamide, NN dialkyl alkanamides. So that you will get NN dialkyl alkanamine, N-alkyl alkanamine, that is alkanamine. Right? Alkanamine, this is N-alkyl alkanamine, this is NN dialkyl alkanamine. If I take two, whatever these groups, same groups are reflected in the product. Right, children? This is. If I take one general example, suppose if I take C2H5 CONH2, then same reagent you will get C2H5 CH2 NH2. This is the amine what I get. Right, children? This is from amides. Next, one from oximes. You know that the oxime structure is C double bond NOH. C double bond NOH. This is oxime. And here, children, you remember that we have two types of oximes. Oximes produced from aldehyde known as aldoxime. Oximes produced from ketones will get ketoximes. This one just you studied the same reaction in the previous chapter. Aldehydes and ketones reacts with hydroxylamines. Aldehydes and ketones reacts with hydroxylamines, so that we will get to oximes. Aldehydes produce aldoximes, ketones produce ketoximes. The same oxime is reduced to amine. The same oxime is reduced to amine. Right, children? So how to produce oxime? Oximes are CHO plus NH2 works. Then this is removed H2O. Then RCH double bond NOH. This is aldoxime. Oxime produced from aldehyde. Then when you take ketone, symmetrical or unsymmetrical, again hydroxylamine, then you will get RCR double bond NOH. This is ketoxime. Aldoximes and ketoximes. These are on reduction gives amines. So I will take aldoxime. Aldoxime means HH or RH. Ketoxime means R and R or R and R dash. So you can take. So example, you take children example, RCH double bond NOH. Reducing agent, I will change this one. I use sodium ethyl alcohol, so that we will get RCH2 NH2 plus H2O. RCH2 NH2. These are all the reducing agents which produce hydrogens. Hydrogen, that is acts as reducing agent. If I take ketoxime, C double bond NOH, ketoxime, then same reagent will get R C R H NH2 plus H2O. Right children, this is aldoxime and this is ketoxime. Aldoximes or ketoximes both can give amines. Let us see the nature of amine. NH2, this is CH2 NH2, again CH NH2. This is a primary amine and this is also a primary amine. So we get primary amines in this oximes. We get primary amines in this oximes. You got it children? So I have discussed 5 methods, right? Nitriles, isonitriles, azides, amides, oximes. Then let us see this one more method, 6th one. This is E and you can go for F. From nitro compounds. From nitro compounds. Suppose RNO2, this is on reduction with LiAlH4, or metal nickel H2. You can take this one, so that this can be converted to RNH2. This is nitro group is reduced to amino group. Similarly, if I take ArNO2, then ArNH2, ArNH2. That is alkyl amine, this is aryl amine, alkyl amine, aryl amine, whatever it may be, right? If you take nitroalkanes, you will get alkyl amines. If you take nitroarenes, so that you will get aryl amines, aryl amines. This is very important reaction for objective also, children. Many times a question was asked based on this reaction. Just I will see this. Take one example, general example. I will take aryl amine, that is nitrobenzene. So nitrobenzene is treated with, I am changing the reducing agent SnHCl or FeHCl. So generally, whichever the reagent is cheaper, lithium aluminum hydride is costlier reagent, so that you can go for tin HCl or iron HCl. This is also reducing agent because both will produce hydrogens. So this you will get NH2. This is aniline. Nitrobenzene gives aminobenzene. Right children? So here just to remember this one, Fe plus HCl is preferred reagent in this reaction. Why we use FeHCl? Because SnHCl or FeHCl both can liberate hydrogen that acts as a reducing agent. But the thing is, when FeHCl, you will get FeCl2 plus H2. So this is the reducing agent, and this FeCl2 undergoes hydrolysis to produce HCl. This is the reason, children. You know that FeCl2 is a salt of strong acid and weak base. It is a salt of strong acid and weak base. So when this undergoes hydrolysis, then what will happen? Cationic hydrolysis takes place. That is, Fe2 plus undergoes hydrolysis so that it produces HCl. So you will get hydroxide from iron ions, iron 2 ions, and HCl from this chloride ions. So therefore what will happen? In this reaction, HCl is consumed, but in this step HCl is produced back. That's why we prefer this one, because the amount of HCl needed, used in this reaction is less when compared to this one. That's why this is preferred, children, because HCl consumed during the reduction process again produced when the salt hydrolyzed. Which is salt hydrolyzed? FeCl2 hydrolyzed. Salt hydrolysis you have studied in the previous class. That is, we do have 4 types of salts. Out of 4 types of salts, one salt never hydrolyzed, that is a salt of strong acid, strong base, never hydrolyzed. Then a salt of strong acid, weak base, hydrolyzed, cationic hydrolysis. A salt of strong base, weak acid undergoes anionic hydrolysis. A salt of strong weak base and weak acid undergoes both anionic as well as cationic hydrolysis. So that's the reason here. So HCl is produced in the reaction due to the hydrolysis of FeCl2, which is produced when iron reacts with HCl, that is in the first step, reduction process. So therefore we will get HCl again. That's why the reaction needs a less amount of HCl. That's why this reaction is preferred, children, right? Then what is the objective bit in this? The bit asked many times, asked number of moles of hydrogen needed in this reaction is, now tell me, how many moles of hydrogen needed for this conversion? So that you can know by seeing these groups. You know that NO2 group changed to NH2 group. NO2 group changed to NH2 group. Right, children? That means what happened? These oxygens are replaced by hydrogens. How many oxygens are replaced? 2 oxygen atoms. You know that oxygen atoms are replaced in this in the form of water molecule. So since 2 oxygens are there, we will get 2 H2O. So 2 oxygens are replaced by 4 hydrogen atoms. 4 hydrogen atoms. That means 2 moles of hydrogen. But it is not the answer, because this oxygen, 2 oxygens, needs 4 hydrogen to remove as water molecule. Again the nitrogen needs 2 hydrogen to change as NH2. So therefore 1 mole, 1 hydrogen, that is 1 mole hydrogen is here, 2 moles of hydrogen is here. Total how many moles of hydrogen needed? It is 3 moles. How many moles of hydrogen needed? 6 moles of hydrogen needed, or 6 hydrogen atoms needed. 6 nascent hydrogen atoms needed for this conversion. Of course, they can stop the bit here. In some papers they asked this one, number of moles, but in some paper they went to some extent. That means they give some amount of this one. That is, it gives 10 grams, 50 grams, 35 grams, 45 grams, something. Some X grams of NO2 gives Y grams of ammonia, or X moles gives Y moles. They can ask in terms of number of moles product formed or in terms of number of grams product formed in the given example. Then you need to apply mole concept. You need to apply mole concept based on stoichiometric calculations. You can go for that. So that was the bit many times asked in IIT JEE and NEET examination. So this is very important bit, children. So number of moles of hydrogen needed to convert 1 mole of nitrobenzene to 1 mole of aminobenzene, that is 3 moles. A number of hydrogen atoms needed for the conversion, 6 hydrogen atoms. Number of grams of means they will give the values based on stoichiometry. You can take 1 mole nitrobenzene needs 3 moles of hydrogen, so that it gives 1 mole of nitrobenzene, that is 1:3:1. 1:3:1, children. Right? This is the one. Next one. So these are the reduction processes. I have given ammonolysis process and reduction process. Then one more important one, Gabriel's phthalimide synthesis. Gabriel's phthalimide synthesis. Right? In this Gabriel's phthalimide synthesis, you need to take phthalimide first. Phthalimide is this is phthalimide. Right? Means this is produced from phthalic acid. What is phthalic acid? When you know this phthalic acid, 2 COOH carboxylic groups at ortho position, that is called as phthalic acid. If 2 carboxylic acid groups are at COOH, this is phthalic acid, right? When they are at meta isophthalic acid, when they are at paraphthalic acid, from this we are going to produce phthalimide. That means generally this is with ammonia, so that you will get COONH4. This is COONH4 plus. Right? Ammonium phthalate. This on strong heating, then you will get CO, C double bond O, NH2, again C double bond O, NH2. This is phthalimide, PH, THA, LAMIDE. This is, see this amide, CONH2. This is imide. CONH2 is amide CONH is imide. This is thalamide. This is thalamide. That means thalic acid is treated with ammonia, so that it gives ammonium salt of thalic acid. Ammonium salt of thalic acid is ammonium thalate. Ammonium thalate on heating gives again thalamide. This thalamide on strong heating so NH3 minus NH3 ammonia is expelled, right? Here water is expelled minus H2O, right children? Here 2 H2O are expelled. In this step water is expelled. In this step ammonia is expelled, so that we will get thalamide, that is CO and CONH. CONH. Right children? So you understood this one. So this also you need to remember. We get thalamide because this one sometimes they will ask us question from starting material. This is for objective. For descriptive you start here, PU. Right? Now I have derived thalamide. Then thalamide is treated with KOH. This is alcoholic KOH. Then you will get CO. This is CO N K plus and N minus. That is potassium salt of thalamide. That is potassium thalamide. This is potassium thalamide. Right children? Potassium thalamide. This potassium thalamide is treated with alkyl halide. Alkyl halide. Here it is nucleophilic substitution. What is the nucleophile here? The negative ion of thalamide. This one. So therefore we will get here the product C double bond O, C double bond O, N R, that is N alkyl thalamide. This is N alkyl thalamide. This is potassium thalamide. This is N alkyl thalamide, and this is treated with aqueous NaOH. Then you will get RNH2. It's a primary amine, or NH2. Then it's a salt COONA plus minus COONA. This is plus minus. This is the product formed. Right children? You can see this thalamide. It's treated with KOH. Again we will get potassium thalamide. Potassium thalamide is treated with alkyl halide. So that N alkyl thalamide, which is treated with aqueous NaOH, so that we will get primary amine. So especially we get primary amines in this. We get primary amines. Right children? So this is alkyl halide is very important. So you can take here alkyl halide as primary, as secondary, tertiary alkyl halides. But in order to get aryl halide, you should not take aryl halide. Aryl halide should not be used in this. Should not be used, because aryl halides will not go for nucleophilic substitution. It is a negative ion of this one is a nucleophile. So aryl halides nucleophilic substitution is very poor because the halogen and carbon bond has a double bond character. This is already discussed in aryl halides. So therefore, aryl halide should not be used in this reaction. Then how to get aryl amides? So here you can use, right children? So therefore, we cannot use this aryl halide. Aryl halide should not be used in this reaction. This is Gabriel's thalamide synthesis. This is thalamide, that is potassium salt of thalamide, potassium thalamide, N-alkyl thalamide and primary amine. Still one more reaction is there children, Hoffman's reaction, Hoffman's degradation, Hoffman's reaction, right? That we will see in the next class. That is also most important for objective examination. So one method left we will see in the next class. Thank you.
सर मॉर्निंग में तो कौन सा क्लास है?
Right. Good morning children. We are under the chapter 3-dimension geometry. So CKSR is on leave, that's why SAR period I am taking. Okay. All of you open page number 493, exercise 11.3, page number 493. Put textbook in front of you. Last class 7th problem was over. Now write 8th problem. Right, 8. Find the equation of the plane. Equation of the plane with intercept 3 on, with intercept 3 on y, on the y axis, on the y axis and parallel to ZOX plane, and parallel to ZOX plane, parallel to ZOX plane. Right, important problem. Okay, solution. Understand the question? Right, we are going to find the equation of the plane. We want equation of plane. Exercise 11.3, all problems related to planes only. 11.2 related, all the problems related to lines. This is planes. We are going to find the equation of the plane with intercept 3 on the y axis and parallel to ZOX plane. We want equation of plane, that plane parallel to the ZOX plane. that plane is required plane is parallel to ZX plane and making intercept 3 on the y-axis and cutting the y-axis at a distance of 3 units. What is the equation of that plane? So, I am drawing the diagram. See, let us consider 3 mutually perpendicular lines, that is x, y and z axis. This is origin O. So, this is xy plane. This place is called xy plane, yz plane, zx plane. We want equation of a plane parallel to zx plane. So, this is zx plane, zox plane. So, parallel plane will be like this. Okay, this plane equation they are asked to get. And that plane is making intercept 3 on the y-axis. This plane cuts the y-axis at a distance of 3 units. This plane cuts the y-axis at 3 units. Automatically this point coordinates are, what are these points coordinates? On y-axis, x value 0, z value 0. So that's why 0, 3, 0 on y-axis, x coordinate 0, z coordinate 0, only y is there 3. I want the equation of this plane. In first PUC I told you, see, what is equation of xy plane? Equation of xy plane is z is equal to 0, because on xy plane z coordinate is 0, only xy will be there. So, z value 0, that is why it becomes the equation, z equal 0. Equation of yz plane is x is equal to 0. Equation of zx plane is y is equal to 0. Equation of zx plane is y equal to 0. So, equation of xy plane z equal to 0. Equation of yz plane x equal to 0. Equation of zx plane y equal to 0. So, this is y equal to 0. Any plane parallel to zx plane is, two parallel planes are differed by constant only. So, this plane equation is y is equal to k, because two parallel planes differ by constant, two parallel lines differ by constant. Similarly, y is equal to k. In order to find k, they given something. What they given is intercept given. It is making 3 units on y axis. Like that we are moving. Draw the figure. Draw this figure. Right. We know that any plane parallel to zx plane, any plane parallel to zx plane is y is equal to k. Say means assume, take this as equation 1. Okay. According into data, intercept given y intercept is equal to how much is 3 units. Okay. Automatically see that this plane is passing through 0, 3, 0. This our required plane is passing through 0, 3, 0. Substitute. So, therefore, equation 1 passes through 0, 3, 0. Then see that if you observe the figure, plane is passing through that point. Substitute that point in the plane equation. In the place of x 0, y value 3, z value 0. Only y is there. So, 3 is equal to k. No x to substitute x 0. No z also, only y is there 3. Reverse it. That implies k is equal to 3. So, what is k value is 3. Substitute in equation 1, you will get the desired plane. So, from 1, the required plane is y is equal to 3. Implies y minus 3 is equal to 0. Okay, that is the equation of the plane parallel to zx plane and making intercept 3 on the y axis. Okay, write it. Okay, any plane parallel to xy plane, any plane parallel to xy plane, formula is z equal to k. Any plane parallel to yz plane is x is equal to k. To get k, they will give something in the problem. Okay, right. See, one note point we are giving. Note. Suppose let us consider a plane. Let us consider a plane. This is origin O of 0, 0, 0. From the origin, perpendicular is drawn. It meets the plane at the point P. From the origin, perpendicular is drawn. It meets the given plane at the point P. Then, how to get the coordinates of P? So, what is the formula to get foot of the perpendicular? This is called perpendicular foot. Foot of the perpendicular. Formula is, so foot of the perpendicular. Foot of the perpendicular, comma P is equal to, formula is LD, comma MD, comma ND. Foot of the perpendicular coordinates formula LD, MD, ND, where L, M, N represents, DCs of normal. So this is normal line. This line DRs we know. ABC. DCs means LMN. D is the distance between the origin and the plane. Okay, write it. So foot of the perpendicular coordinates formula LD, MD, ND. LMN represent DCs of normal. D is the distance between origin and the plane. Write it same. Okay, right. Example 16. Example 16. Find the coordinates of the foot of the perpendicular drawn from the origin to the plane 2x minus 3y plus 4z minus 6 is equal to 0. 2x minus 3y plus 4z minus 6 equal to 0. Okay, solution. Important for 3 marks. 3 marks important question. Right, understand? We are going to find the coordinates of the foot of the perpendicular drawn from the origin to the plane. Here plane is given, origin is given. From the origin perpendicular is drawn. So what are the coordinates of the foot of the perpendicular? See, here plane is there, origin is there. From origin perpendicular is drawn. It meets the plane at the point P. Then P is called foot of the perpendicular. Then what are the coordinates of P? So just now I given the formula. What is formula is LD, MD, ND. Means change that plane into normal form. To change if plane is there, I want LMNO. That's why change that plane into normal form. Okay, write the given plane. Draw the diagram. Right, given plane is 2x minus 3y plus 4z is equal to 6. Okay, I am going to change this plane into normal form. Normal form, what is normal form? D is there na, so I am doing like that. So what is normal form formula? Lx plus My plus Nz is equal to D. Lx plus My plus Nz equal to G. So, to change any plane into normal form, divide entire equation by root of a square plus b square plus c square. So, divide it by root of a square plus b square plus c square is equal to root of, it is in the form ax plus by plus cz is equal to d. Ax plus by plus cz equal to d. So, a square means 2 square is 4, minus 3 whole square 9, 4 square 16 is equal to root 29 on both sides. So, divide each term by root 29. So, 2 by root 29 into x minus 3 by root 29 into y plus 4 by root 29 into z is equal to 6 by root 29. Divide each term by root 29. It is in the form Lx plus My plus Nz equal to D. Okay, this is in the form. Otherwise, compare it with Lx plus My plus Nz is equal to D. We get L is equal to L means x coefficient is 2 by root 29, comma, m is equal to minus 3 by root 29, comma, n is equal to 4 by root 29, comma, d is equal to 6 by root 29. L, m, n, d values. Therefore, foot of the perpendicular, comma, P is equal to formula LD, comma, MD, comma, ND, right, is equal to LD. L is there, D is there, LD. Okay. So, 2 by root 29 into 6 by root 29, comma, LD. MD means minus 3 by root 29 into 6 by root 29, comma, 4 by root 29 into 6 by root 29. LD, MD, ND is equal to 2 6 are 12 by root 29 into root 29 is 29, comma, minus 18 by 29, comma, 24 by 29. Okay, those are the foot of the perpendicular coordinates. I used shortcut method. In textbook they given long method. We used shortcut formula LD, MD, ND. Okay, do it. Write that question. Right. Under the exercise we are doing fourth problem. Under the exercise fourth problem. In the following cases, comma, find the coordinates of the foot of the perpendicular, coordinates of the foot of the perpendicular, foot of the perpendicular drawn from the origin, drawn from the origin, drawn from the origin. In that one they given 4 questions. I am doing 2 problems homework. So B problem I am doing now. B, 3y plus 4z, 3y plus 4z minus 6 is equal to 0. 3y plus 4z minus 6 equal to 0. Okay, solution. Understand the question. Here one plane is given, origin is given. From the origin perpendicular is drawn, it meets the plane at the point P. Here P is called foot of the perpendicular. Okay, we are going to find the coordinates of foot of the perpendicular. Coordinates of the foot of the perpendicular. We know formula LD, MD, ND. L, M, N are DCs of normal. D is the distance between origin and the plane. That's why change the plane into normal form. Normal form formula Lx plus My plus Nz equal to D. Okay, write down the given plane. Send the constant to that side. Given plane is 3y plus 4z is equal to 6. Okay. To change any plane into normal form, first problem we did, divide the each term by root of a square plus b square plus c square. So divide it by root of a square plus b square plus c square is equal to root of here x not there, so 0 square plus 3 square plus 4 square, right, is equal to root of 9 plus 16 is equal to root 25 is equal to 5 on both sides. So divide each term by 5 on both sides. So 3 by 5 into y plus 4 by 5 into z is equal to 6 by 5. Divide each term by 5. Right. Compare it with standard form. Compare it with Lx plus My plus Nz is equal to D. We get L is equal to 0 because no x coefficient here 0, comma M is equal to y coefficient is 3 by 5. Comma n is equal to 4 by 5, comma d is equal to 6 by 5. Okay, L, M, N, D values came. Now formula foot of the perpendicular is equal to foot of the perpendicular, comma P is equal to LD, MD, ND is equal to L means 0 into D 6 by 5, M 3 by 5, D 6 by 5, comma 4 by 5 into 6 by 5. Right, 0 and anything is 0. 3 6 are 18 divided by 25. 4 6 are 24 divided by 25. Okay, that is the foot of the perpendicular coordinates. Okay, right. D problem I am doing now. D. 5y plus 8 is equal to 0. 5y plus 8 is equal to 0. Okay. Here one plane is given. We are going to find foot of the perpendicular coordinates drawn from the origin to the plane. Okay, write the given plane. Right, given plane is 5y plus 8 is equal to 0. Send constant to that side. 5y is equal to minus 8. RHS constant is always positive because it represents distance. Distance is always positive. So to make it positive, multiply with minus on both sides. So minus 5y is equal to 8. To make positive, multiply with minus sign. Write in order. 0 into x minus 5y plus 0 into z is equal to 8. Change this plane into normal form. To change that one, divide it by root of a square plus b square plus c square on both sides. So divide it by root of a square plus b square plus c square, right, is equal to root of 0 square is 0 minus 5 whole square 25 plus 0 square 0, root 25 is 5 on both sides. So divide each term by 5. Okay, 0 by 5 into x minus 5 by 5 into y plus 0 by 5 into z is equal to 8 by 5. 0 by anything is 0 into x, 5 cancel, 1 into y, 0 by anything 0 into z is equal to 8 by 5. Right, compare it with Lx plus My plus Nz is equal to D. We get, compare it with Lx plus My plus Nz is equal to D. We get, write L, M, N, D values. L is equal to 0, comma, M is equal to minus 1. N is equal to 0, comma, D is equal to 8 by 5. Therefore, foot of the perpendicular P is equal to LD, comma, MD, comma, ND, right, is equal to, substitute all the values. L value 0, 0 into 8 by 5, minus 1 into 8 by 5, 0 into 8 by 5, right, is equal to 0 into anything is 0, minus 8 by 5, comma, 0. So foot of the perpendicular coordinates are 0, minus 8 by 5, 0. Okay, you do A and B as homework. Write down ninth problem. 9 under the exercise only, ninth problem. Okay, this is given in March 2015, 18, 20, and also important problem for 3 marks. 2015, 18, 2020. This year March asked. Okay, write the question. Find the equation of the plane. Equation of the plane through the intersection of the planes. Through the intersection of the planes. Through the intersection of the planes. 3x minus y, 3x minus y plus 2z minus 4 is equal to 0, and x plus y plus z, x plus y plus z minus 2 is equal to 0, and the point 2 to 1, 2 comma 2 comma 1, 2 to 1. Right, solution. Understand the question carefully. See, we are going to find the equation of the plane through the intersection of the planes. 3x minus y plus 2z minus 4 equal to 0, and x plus y plus z minus 2 equal to 0, and the point 2 to 1. Here two planes given. If they intersect, a line can be formed. What is the equation of the plane passing through the intersection of the planes? See, this is one plane. This is another plane, intersected. Two planes intersected. What happened? Line is formed. This is one plane. Our hand is one plane. This is another plane. So, if two planes intersect, what is formed is line is formed. Line is formed. So, line formed. So, what is the equation of the plane passing through the intersection of these two planes? So, what is the plane passing through that intersection? I given the formula before the exercise, intercept formula after that given. So, formula is pi 1 plus lambda pi 2 is equal to 0. Pi 1 plus lambda pi 2 equal to 0, where lambda is a constant. To get lambda, they will give something in the problem. What is that something is? That plane is, required plane is passing through the point 2 comma 1. Our required plane passing through this point. So, what is that plane equation? Okay, apply the formula, you will get the answer. Draw the figure. Right, given planes are 3x minus y plus 2z minus 4 is equal to 0, x plus ya plus z minus 2 equal to 0. Okay, take this as equation 1, this as equation 2. I assumed given planes as 1 and 2. We know formula. Let the equation of a plane, let the equation of a plane passing through intersection of planes 1 and 2 is, planes 1 and 2 is, intersection of planes 1 and 2 is, this is first plane, this is second plane. first plane, this is second plane. Planes 1 and 2 is formula we know phi 1 plus lambda phi 2 is equal to 0. Phi 1 means first plane, phi 2 second plane, phi 1 equal to 0, phi 2 equal to 0. Phi 1 is 3x minus y plus 2z minus 4 plus lambda into pi 2 x plus y plus z minus 2 is equal to 0. So, pi 1 substituted, pi 2 substituted. Take this as equation 3. After getting lambda, we can substitute here. So, take that as equation 3. To get lambda, parameter, scalar, constant, they give something. This plane is passing through 2 to 1. If it passes through, if it passes through 2 comma 1, then what will happen? Substitute that point in the plane equation. Where? In the place of xyz. 3x means 3 into 2 minus 2 plus 2 into 1 minus 4 plus lambda into 2 plus 2 plus 1 minus 2 is equal to 0. Substitute in the place of xyz 3 into 2 minus y value 2 plus 2 into 1 minus 4 plus lambda into 2 plus 2 plus 1 minus 2. Here plus 2 minus 2 cancel. 3 2 ja 6 minus 2 plus 2 minus 4 plus lambda into 2 plus 1 3 is equal to 0. Here minus 2 plus 2 cancel. 6 minus 4 2 plus 3 lambda is equal to 0. 3 lambda is equal to plus 2 become minus 2. Lambda is equal to minus 2 by 3. Okay, that is value of lambda. Lambda is equal to minus 2 by 3. Substitute that lambda value in equation 3, you will get the required equation of plane. From 3, the equation of required plane is okay. Substitute that lambda value here. 3x minus y plus 2z minus 4 into plus lambda value minus 2 by 3 into x plus y plus z minus 2 is equal to 0. X plus y plus z minus 2 equal to 0. Simplify. Okay, I am taking the LCM. LCM is 3. I am taking the LCM 3. Numerator 3 into this term. So 3 into 3x minus y plus 2z minus 4 plus into minus 2 minus 2 plus into minus 2 minus 2 into x plus y plus z minus 2 is equal to 0. Okay, multiply 3 3 ja 9x, 3 3 ja 9x minus 3y, 3 2 ja 6z, 3 4 ja 12 minus 2 into x minus 2x minus 2y minus 2z plus 4 is equal to 3 into 0 0. Cross multiplication 3 into 0 0. Simplify. That implies 9x minus 2x. 9x minus 2x is 7x minus 3y minus 2y is minus 5y, 6z minus 2z is 4z, minus 12 plus 4 is minus 8 is equal to 0. Okay, that is the equation of the plane passing through intersection of two planes and also point 2 to 1. Right, important question for 3 marks. You know 1 mark, one mark question where it comes from first exercise, 3 marks from this one, 5 marks questions are theorems, compulsory one theorem for 5 marks. Okay, write it. Okay, we are having a CET exam, indefinite integration, 25 questions are there, practice it. Now if you have a time is there, so practice it. Only 2 chapters remaining in this PUC, that is LPP and probability. LPP carries 7 marks, linear programming problem. LPP carries 7 marks, probability carries 11 marks, means 18 marks. So out of 150 marks, only 18 marks are remaining. Within 3 days, I am going to complete this planes chapter also. So within 3 days. Okay, thank you. We will meet on Monday. Thank you.
ఆఫ్టర్ చూసుకోండి క్లాస్ స్టార్ట్ అయింది సార్ కంటిన్యూ ఉంది మైక్ తీసుకొచ్చేస్తాను
అంతే
రాబోస్ పట్ల ఆనైందా ఆనైందా Good morning children, welcome to biology online class. Since last class we are discussing about microbes in human welfare. So within the chapter we discussed about microbes in the industrial products, in the production of industrial products. So within that we discussed about fermented beverages, antibiotics, and in yesterday class we start discussing about microbes in the production of enzymes, chemicals, and as well as other bioactive molecules. In the last class we discussed about different type of organic acids which are produced from different type of microorganisms. Those are very important for competitive examination children. Citric acid, it is from Aspergillus niger. Acetic acid is from Acidobactericidae. Next, lactic acid, it is from Lactobacillus, that is nothing but lactic acid bacterium. Butyric acid, that will be isolated from Clostridium botulinum. So like the different type of acids generally, and we discussed about their uses also. And today's class we are going to discuss about enzymes and as well as other bioactive molecules. Enzymes and other bioactive molecules. Right children, in the last class itself we discussed about the production of ethanol from Saccharomyces cerevisiae. So it is also one of the industrial product which generally we will get from microorganisms. So already we know the uses of ethanol. Ethanol is widely used in many ways, industrial level. If you take for example whatever the sanitizers we are using nowadays for disinfectant of our hands, generally it is synthesized from generally it contain more amount of ethanol. Not only that, in the last class we discussed about the importance of ethanol in biotechnology, that is nothing but RDNA technology. So within that, ethanol is used to isolate the DNA from other molecules as a precipitation. So not only that children, ethanol is also used in the preparation of some medications, say for example cough syrups and as well as other medicines. So like that, ethanol is also one of the industrial product. It is also we are isolating from the microorganisms only. Here that microorganism is nothing but Saccharomyces cerevisiae. Now we are going to discuss about different type of enzymes and their uses, and these are also isolated and obtained from the microorganisms only. The best example is, first one is lipase. It is an enzyme Lipase is an enzyme. It is produced from bacteria and fungi. Lipase. What is the function of this lipase enzyme? Ase means if any name of an enzyme is any type of name, it is having suffix as a ase, that is nothing but a enzyme. Here lipase means this enzyme acts on lipids, which means it will break down or oxidates only lipids only, which means here this particular enzyme in industrial level, it is used for the formulation of detergents. It is used for formulation of detergents, which means children, this lipase enzyme is having a special capability that is nothing but which can remove oil stains from the cloths, which will remove the oil stains. Oil stubborn stains from the cloth. So that's why this lipase enzyme is used nowadays for the formulation of detergents. Whatever the detergents we are using for the washing the clothes, in that particular detergents, in generally in industrials they will use what type of enzyme, children? A lipase enzyme. So if you use this enzyme in this formulation of detergent, these detergents can be easily used and they can remove the stains like that particular oil and as well as other type of stains. So that's why nowadays children, this lipase enzyme, it is produced from bacteria and fungi. It is used in the formulation of different type of detergents. Very, very important for competitive examination. Lipase enzyme. So it is also isolated from microorganisms only. All these chapter explains only the importance of the microorganisms in our daily life and as well as in industrial level. That is only we are going to discussing in this chapter. So here lipases, even though this one is used in industrial scale or industries and as well as different type of factories, but all these things are isolated from microorganisms only. And next, pectinase and protease. These two types of enzymes widely used in the preparation of juices. If you take for example, if you go to the supermarkets and as well as other type of markets, children, if you see the juice bottles are very clear. If you observe the juice prepared in your home and as well as if you buy the juice from the market, there is a slight differentiation in the bottle. Whereas in the juice you purchase it from a supermarket, the juice bottle is very clear, at the same time juice will be appeared very clear. But whatever the juice, the same juice which is prepared in your home, that juice is not clear. Why? Because still it is having some amount of pectin and as well as some type of protein. So that's why it is not clear. When you when you purchase a particular juice in a market or supermarket, that will be very clear. Why? Because due to this pectinase and as well as protease. The function of pectinase is nothing but which will break down the pectin. We already know that some of the plant cell walls, they are composed of pectin and as well as cellulose. If you use this pectin, obviously whatever the pectin present in that particular fruit juice, which will be disintegrated and as well as it is totally oxidated. And come to the proteases. What is the function of proteases, children? Which will break down the proteins. How it will be break down? Very simple, children. This protease enzyme breaks the peptide bonds. Very, very important for competitive examination. Which will oxidize the peptide bonds present in the proteins. So obviously, when the peptide bonds peptide bond breakdown takes place, what happens, children? Here, the amino acids will be separated. So whereas if you take the juice which is prepared in your home, due to the absence of these enzymes, some protein and as well as pectin, they are still remain in your juice. So that's why it is not clear. So when you take the same juice from the supermarket, the bottle is very clear. Why? Because this type of pectin and as well as proteins are absent. Only what is that particular juice will be present in that bottle. So that is the reason why the juice bottles are very clear when you purchase in the supermarket. Why the same juice if you prepared in your home, it is not clear? Because of the presence of this pectin and as well as different type of protein. All such a thing, type of things are break down by using these two enzymes, that is nothing but pectinase and protease. What is the function of pectinase and protease, children? Clear the juice. It will remove whatever the unwanted molecules like proteins, different type of proteins. Even though after juice making, still some proteins and as well as some amount of pectin is present, so that will be easily cleared by using this particular two enzymes called pectinase and as well as protease. So this is about lipase and as well as pectinase and proteases, which are widely used in industrial scale level because to prepare juices and as well as already we discussed about in the preparation of detergents. And now we are going to discuss about enzyme which is used as bioactive molecule. Enzymes and bioactive molecules which are useful in the field of medicine. Best example is streptokinase. This enzyme is produced from streptococci. What is the name of the bacteria, children? Streptococci. Streptococci bacterium in generally produces this streptokinase enzyme. This streptokinase enzyme is also called as clot buster. What is this clot buster, children? Very simple. This streptokinase enzyme removes whatever the clots which are present in the blood in generally near to the heart vessels. If any clots are present, this streptokinase enzyme will remove all that particular clots present in the near to the heart vessel. So that's why it is called as clot buster. Generally this streptokinase enzyme, this clot buster is used to remove the clots from the blood vessels of patient who have undergone myocardial infarction. So what is the name of disease, children? Myocardial infarction. Due to this myocardial infarction, there is the formation of clots in the blood vessels near to the heart. So when you use this streptokinase enzyme which will remove the clots present in generally the disease called myocardial infarction. If this myocardial infarction is continuity is there, obviously which will leads to heart attack. This myocardial infarction leads to heart attack. So that's why to reduce the effect of the heart attack we will use in generally this streptokinase enzyme. Very, very important for competitive examination. It is also called as clot buster. It is used in the treatment of myocardial infarction. It will lead to the heart attack. So that is about the enzyme streptokinase. So some another two bioactive molecules are there. These two are also widely used in the field of the medicine. The first one is cyclosporin A. Cyclosporin A, very, very important for competitive examination, children. It is not an enzyme, but it is a bioactive molecule. It is one of the molecule which is obtained from microorganisms only. So it is also having lot of importance in the field of medicine. So generally this cyclosporin A is produced by a fungus called trichoderma polysporum, very very important for competitive examination. Cyclosporin A is produced by what type of organism it is? Either bacteria or fungi? It is a fungi. So that fungi name is Trichoderma polysporum. What is the function of this cyclosporin A? So generally cyclosporin A is used as an immunosuppressive agent in organ transplant patients. It is used as an immunosuppressive agent in organ transplant patients. So due to any problem, see for example, you may heard about kidney failures to patients and as well as liver failures to patients. In such a type of cases, children, they need a new kidney. What happened when the kidney is transplanted? Their body is not adjusted for the new kidney. Obviously, it will increase some immunological responses. So by that, there will be a formation of sometimes some types of allergies. In generally in patients which are undergoes organ transplantation children, that particular patients will in generally suffer with allergies. Why? Because that particular organ is not their origin. Particularly, it is not a origin. Particular organ it is not originated from themselves. So that's why there will be some allergies. To reduce that particular allergies in organ transplant patients, we will use this cyclosporin A. Very very important. What is the function of cyclosporin A? It is used as an immunosuppressive agent. Very very important for competitive examination. It is used as an immunosuppressive agent in organ transplant patients. So generally cyclosporin A is obtained or produced by a fungus called Polysporum, Trichoderma polysporum. And the last one, statins. Statins, it is produced by a fungus, the yeast called Monasus purpureus. Very very important for competitive examination. Its name was Monasus or Monascus purpureus. It is the name of the fungi which produces a bioactive molecule called statin. Generally, this bioactive molecule, that is statin, is also called as blood cholesterol lowering agent. Very very important for competitive examination. What is the function of this statins, children? It will reduce the cholesterol percent present in the blood. There is a quite differentiation between clotbuster and as well as statin. Both are not same. Both are totally different. What is the function of clotbuster? It will remove the clots present in the blood that will be formed by myocardial infarction, which will lead to the heart attack. Then what about statins? It will reduce the it will reduce the cholesterol percentage present in the blood. That is the main function of the statins. So that's why there is a differentiation between statins and as well as clotbuster. So you should remember that particular differentiation, or otherwise you will be automatically undergone the confusion, children. So clotbuster means it will remove the clots in the blood. Statins are nothing but it is called as blood cholesterol lowering agent. So this is about the bioactive molecules which are produced by different type of microorganism. We discussed about Clotbuster, that is streptokinase produced from Streptococcus bacteria. Next, fungi, it produces cyclosporin A. It is also called as immunosuppressive agent, right? So for organ transplant patients, that is nothing but cyclosporin A, which is produced from Trichoderma polysporum, very important for competitive examination. Next, statins, it is produced by a fungus, its name was yeast, right? It is produced from Monascus purpureus or Monassus purpureus. So it used as blood cholesterol lowering agent. So in general, it acts by competitively inhibiting the enzyme responsible for synthesis of cholesterol. So it will inhibit the function of enzyme synthesizing, what is that, cholesterol synthesizing enzyme. When it will bind to the cholesterol synthesizing enzyme, there is no production of any cholesterol. So by that there will be a reduction and a reduction and as well as inhibition in the synthesis of cholesterol by the enzyme. So this is about the enzymes and as well as other bioactive molecules which are synthesized or produced from the microorganisms. So by this we discussed microbes in industrial products. We are getting a lot of industrial products from microorganisms. Best example, fermented beverages, antibiotics, enzymes, chemicals and bioactive molecules. Now we are going to discuss about microbes in sewage treatment. Microbes in sewage treatment. This topic is very important for PUC examination, children. Many times asked for 5 marks question. Explain the sewage treatment process, generally in cities. Before we are going to discuss about the process of sewage treatment, first of all we should know what is a sewage. Before we are going to discuss about the sewage, children, due to the urbanization and as well as industrialization in the cities and as well as in urban areas, especially in towns, there will be increasing of or there will be a production of large amount of waste products from the homes. That waste products all are segregated in the water only. The majority of the waste present in the municipal wastewater is nothing but human excreta. The large amount of this presence of large amount of this human excreta in the water, it will lead to the lot of causing of lot of diseases to the human beings, and not only that, it will lead to the pollution also. It will lead to causing of different type of diseases in animals also. Whatever the municipal wastewater which is produced in the cities, towns and as well as villages, that municipal wastewater is called as simply sewage. Very important. All municipal wastewater is called sewage. What is the need of sewage treatment? What happened when all these sewage, that is nothing but municipal wastewater, these municipal wastewater, what is the fate of municipal wastewater, children? Again, these wastewater should be enter into the rivers and as well as lakes and as well as oceans. So by that, if the sewage water does not have any pollution and as well as any organic matter, it can be easily discharged into the rivers, lakes and as well as oceans. When it is having all these polluted organic matter, what happened when it is discharged into the rivers and as well as oceans? It will lead to the pollution of rivers and oceans. So by that, whatever the animals and whatever the organisms which are present in the ocean and aquatic food chain, they will lose their life. So by that, it will lead to, what is that? Extinction. And not only that, if you are continuously discharging the particular wastewater, municipal wastewater, it is having all the waste. It is having suspended solids, plastic covers, papers, small, what is that? Soil and as well as pebbles, small stones are present in this particular municipal wastewater. And not only that, it is having human excreta. What happened when you are released or discharged this particular municipal wastewater into the lakes and as well as water bodies? After some years, after nearly some 20 to 30 years, whatever the water bodies present in that river and as well as lake, they will be converted into soil. They can be converted into terrestrial habitats. That is also called as eutrophication. You may study it in environmental issues. I think it is already over. In environmental issues is there. Eutrophication. Accelerated eutrophication is there. That is nothing but it is a process by which a conversion of a water body into soil. That is nothing but eutrophication. This municipal wastewater leads to formation of eutrophication. When the eutrophication takes place, the particular aquatic organisms undergoes the extinction. If there is no water, obviously what about the fish? What about the planktons? What about other organisms present in the aquatic water body, children? Obviously they undergoes extinction. So that's why this municipal wastewater should undergo some treatment. Treatment is nothing but to remove all the polluted components present in the municipal wastewater. That is nothing but sewage treatment. Here we should remove all the suspended solids like papers, plastic covers, sand, and as well as human excreta. So by that, the particular sewage water will be totally cleaned, and now that water can be easily discharged into the river. So then only it will be safe for discharging into the aquatic water bodies, or otherwise it will lead to eutrophication and it will increase the pollution present in the water bodies. So that's why we should develop sewage treatment plants. There will be a need of development of sewage treatment plants in all over the cities. Nowadays in our India, due to the development, every village nowadays it is now going to be developing into a town. Every town is nowadays developing into a city. When it is development takes place, obviously there will be a production of more amount of pollution also takes place. So municipal wastewater will be produced more in urbans and cities. So that's why there is a need of development of more sewage treatment plants. Simply we will call it as STPs. So in these topics we are going to discuss about what is the working procedure of sewage treatment plant. So how the sewage water undergoes the treatment. So how many phases are there? In that phases, what type of procedures will be takes place, and after that the water will be discharged into the rivers and as well as aquatic water bodies. All those things we are going to discuss now itself. So now we are going to discuss about the working procedure of sewage treatment plant. So generally there are two steps are there in sewage treatment. There are two steps in sewage treatment. One is primary treatment and the second one is secondary treatment. Two treatments are there in sewage treatment plant, right? One is primary treatment and the second one is secondary treatment. So now we are going to discuss about the primary treatment in this class. In tomorrow class we are going to discuss about secondary treatment along with primary treatment itself. So once again I am telling this one is very important for PUC examination, especially for 5 marks. So please you should read this topic and you should understand compulsory. Primary treatment is also called as physical treatment. It is also called as physical treatment. Why it is called physical treatment? Because in this step or in the primary treatment, there will be a removal of all the suspended solids and as well as soil particles and pebbles will be takes place in the primary treatment. It removes all suspended solids in soil pebbles. Pebbles are nothing but small stones, right? So in the municipal wastewater, mainly there are two polluting agents are there. Mainly two polluting agents are there. One is suspended solids, waste materials like solid materials. Say for example, papers, plastic covers, all soil particles, all are nothing but suspended solids. And the second one, polluting agent, is nothing but organic matter. Whatever the vegetable waste and human excreta and other excreta, all are nothing but organic waste. So in the sewage treatment, to remove the one type of component, that is nothing but all suspended solids and other type of soils and pebbles, we will use the primary treatment. And to remove the organic matter present in the polluted water body, we will use the second treatment, that is nothing but secondary treatment, that is also called as biological treatment. Again, we are going to discuss about what is that biological treatment and all. Come to the primary treatment, it removes all suspended solids and soil and pebbles. How it will be removed? That is the major problem here. There are two steps are there in primary treatment. One is filtration. Second one is sedimentation. Filtration, sedimentation. By the process called filtration, we can remove all suspended solids. Say for example, by the process of filtration, if you perform that filtration process, whatever the large particles which are present in the water body, all will be suspended at the top only. Remaining all the liquid particles will be comes to the bottom. That is nothing but filtration process. By the filtration process, we will remove the suspended solids. Then what about soil and as well as pebbles? Still they are present in the water body and they are very small, so they can be easily passed through the filtration. So that's why we will go for the second process, that is nothing but sedimentation. This process will be takes place in the particular tank called primary settling tank. The sedimentation takes place in primary settling tank. Very simple, children. In this process of sedimentation, the particular whole water body undergoes, what about that? The soils and pebbles will be sedimented at the bottom by the process called agitation. Here agitating is nothing but that particular whole water body undergoes, what is that? It will be rotate. When it will be rotated by the agitating, whatever the soil and pebble and other particles present in sand particles present in the water body, they will be sedimented at the bottom. So to remove the soil and pebbles, we will use the sedimentation. Sedimentation is nothing but it is a agitating system. Agitating means it will be rotate. When it will be rotating, whatever the huge particles which are present, more density particles which are present, they will be sedimented at the bottom, and remaining lightweight or light density particles, they will be segregated at the top. That is called as supertenant, and whatever the particles which are sedimented at the bottom, those are called as pellet. Imagine it is the primary settling tank, children. So in this primary settling tank, the organic matter along with the water which will be sedimented at the top. Now this layer is called as supernatant, and whatever the density particles like soil and as well as pebbles, this is called as sediment. This is called as sediment. So in the sedimentation process, due to the agitation system, all the organic matter will be sedimented at the top and remaining soil and pebble will be sedimented at the bottom. So whatever the sediment which is called, which is in generally soil and pebbles, this particular sedimentation is called as primary sludge. It is called as primary sludge. Very, very important. What is the primary sludge? It is a sedimentation of soil and as well as other pebbles and as well as sand particles. All are nothing but we will call it as a primary sludge, and primary sludge formation will be takes place in primary settling tank. What happened in the primary settling tank? There will be a sedimentation. Sedimentation will be takes place by a agitation system. So by that, all the soil and pebble particles will be sedimented at the bottom, and remaining organic matter will be present at the top. It is nothing but effluent. Whatever the soil particle pebbles which are sedimented at the bottom, that is nothing but sedimentation. That particular sedimented solid and soil and pebble particles are called as primary sludge. And now from the primary settling tank, whatever the effluent is there, effluent means supertenant. Supertenant is nothing but whatever which is floating at the top, that is nothing but supertenant. Now this supertenant will be undergoes the secondary treatment. So what type of components are present in the supertenant, children? Still it is having organic matter. What is that organic matter? It may be vegetable molecules or vegetables, and as well as human excreta. Whatever the organic matter which is present in the polluted water body, that will be sedimented at the top after sedimentation process. And remaining the solid particles like soil and as well as pebbles, they will be sedimented at the bottom. Now this effluent, after sedimentation, the effluent or supertenant which is present, that effluent will be transported for the secondary treatment, that is nothing but biological treatment. The tomorrow class we are going to discuss about that secondary treatment or nothing but biological treatment. Now you can understand what is primary treatment. What is sewage? First of all, sewage is nothing but municipal wastewater. So what type of components are there in municipal wastewater? Suspended solids and organic matter. So there are two steps are there in sewage treatment that will be takes place in sewage treatment plant. One is primary treatment, second one is secondary treatment. Primary treatment is called as physical treatment. There will be removal of all suspended solids and soil particles and pebbles will be takes place. There are two steps. First one is filtration, second one is sedimentation. By the process of filtration, we will remove all suspended solids like papers and plastic covers. And the second process, that is nothing but sedimentation. Here by agitating system in primary settling tank, there will be a removal of soils. There will be a separation of soil particle and as well as organic matter. All soil particles will be sedimented at the bottom, that is called as primary sludge, and whatever the supertenant that will be floating at the top, that effluent is having all organic matter. Now that effluent will be undergoes what is the next treatment, that is nothing but secondary treatment. Now this effluent is transported to the aeration tank. Next class we are going to discuss about all those things. So this is about the sewage treatment, primary treatment, children. So in this class we discussed about chemicals, enzymes and other bioactive molecules which are produced from microorganisms. So we discussed about different type of organic acids which are produced from bacteria and microorganisms. So organic acids, there are 4 organic acids we discussed, very important. Antibiotics. Do you remember that antibiotics, children? We discussed about penicillin, which is isolated from Penicillium notatum. It is a name of fungi. And next in the yesterday class itself we discussed some diseases. For their treatment, what we will use, what type of antibiotics. Say for example plague, we will use for plague doxycycline and as well as streptomycin. And next whooping cough, for whooping cough we will use azithromycin. And next diphtheria, for diphtheria we will use in generally penicillin and as well as erythrocycline. And next for leprosy we will use fluoroquinolones. So we discussed about all those things in the last class only. And today afternoon you are going to write the objective test, I think. So for that we already announced the syllabus also, that is biotechnology, principles and processes. In yesterday class we discussed about some questions from that particular chapter, from the material also. So all the questions are strictly from the textbook only, children. If you are thorough in the textbook, you will get full marks. 25 questions are there. So nearly 100 questions. Within that 100, PCMB is there. That is nothing but physics 25 questions, chemistry 25, mathematics 25 and biology 25. And you should answer all the questions. it is for 100 marks. There are no any negative marks, children. So please read the textbook, understand the concept first of all, biotechnology principle and processes. If you do have any doubts, you can call me and you can send your doubts by the WhatsApp messages, and I will clarify all your doubts. So again and again I am telling, these chapters are very, very important, and now time is going on very fast. You have very less time. The exams may be they are going to be conducted in the month of May or April. So already we are near to the completion of syllabus. If you have finished this microbes and human welfare, we will complete our second year syllabus, and next we are going for repetition and as well as revision, and we are going to complete our NEET syllabus also. Still we have to do NEET syllabus, still we are in genetics only. So still many chapters are there. So that's why children, you should take it very seriously. Read textbook every day, especially for biology. You should read the textbook, or otherwise you won't get marks in the competitive as well as PUC. If you read the textbook, which will be useful for both the examination, that is PUC and as well as competitive examination. Whatever it may be the question paper, what type of questions may be asked, if you have the concept in your mind, you can give perfect answer to the particular question. So please read the textbook. So take seriously from today onwards. Don't waste the time. The time is very less. So November is going to be finished and the December will be start. So that's why children, take it seriously. Prepare for competitive examination, especially not only for theory, those who are preparing for NEET and as well as CET. Start your studying from today onwards. So this is about microbes and human welfare. Remaining concept we are going to discuss from tomorrow classes. Thank you so much. Well, start